Hello, here I am again with a new topic called mensuration. So let me tell you what mensuration is. Mensuration is a branch of mathematics, a part of mathematics which deals with the study of different geometrical shapes and calculation of their areas and volumes. So mensuration is a part of mathematics which is related to the different geometrical shapes and the calculation of their areas and volumes. But before we begin mensuration, that is the calculation of areas and volume, we should understand this term, that is perpendicular. What a perpendicular is. You can see here is the definition of perpendicular. When two line segments meet at a point and forms an angle of 90 degree, a right angle, the line segments are said to be perpendicular to each other. That means when two line segments, here I have two line segments here. You can see AB and BC are two line segments. The line segment AB meets CB at the point B, and the point where they meet forms an angle of 90 degree. So the line segment AB is said to be perpendicular to BC, and the line segment CB is said to be perpendicular to AB. Similarly, we have the line segment here PQ and AD. So AD meets PQ at the point D, and the point where they meet forms an angle of 90 degrees. So we can say that AD is perpendicular to PQ, or QD is perpendicular to AD, or PD is perpendicular to AD. Here you can see I have placed two of my pens in this position and now the red pen and the gray pen meets at this point, and the point where they meet forms an angle. This angle is 90 degree. We usually denote 90 degree by a square box. So now it can be said that the gray pen is perpendicular to the red pen, and the red pen is perpendicular to the gray pen. Once again, let's see. I have a green surface here. If I place a pen vertically upright, then it forms an angle of 90 degree with the green surface. A vertically upright object forms an angle of 90 degree with the surface. So it can be said that the pen is perpendicular to the green surface. So by now you must have an idea of what a perpendicular is. So now let's move on to next part, that is triangle. You know why I chose triangle? Because in our next part we are going to calculate the areas and volumes of triangular prism. So the idea of triangle is very important for the calculation of areas and volumes of triangular prism. So that is why I focus on triangle here. Here we have a triangle. Let's take a look at the definition of triangle. Okay, the word triangle, tri means three, angle, we have three angles in a triangle, so it is called a triangle. Triangle is a closed figure with three sides, and it has three angles, interior angles. A triangle is a closed figure with three sides. The three sides are this blue side, you can see AB. We can name it AB or BA, and then we have red side BC or CB, and the pink side AC or CA. So this figure is called triangle. It has three sides, and in this figure too we have three sides. The orange side PQ, and the green side QR, and the blue side PR or RP. So this is the figure of triangles. You know, a triangle has three sides, three vertices. Here the vertex is the point where the line BA and CA meets. The line segment meets, where the line segment BA and CA meets. And B is also the vertex where the line segment AB and CB meets. C is also one of the vertex of this triangle where the line segment AC meets BC. So now you must know what a vertex is. A vertex is a point where two line segments meet to form an angle. And we have angle. We call this point is called vertex, and the corner where the two lines meet each other, they form a corner, and this corner is called angle. So we have here angle, this part is called angle, and this part is called angle. You know the symbol used to denote an angle here. So you know now what a vertex is, sides of a triangle, and angle of a triangle. Here take a look on the properties of triangle. This properties of triangle is applicable to all form of triangles. So the first properties of the triangle is a triangle has three sides, three vertices, and three angles. As you can see, a triangle has three sides. The side AB, BC, and CA are the three sides, and it has three vertices A, B, and C, and three angles. You can see we have three angles inside, three corners. So, and the next property is the sum of the three interior angles of a triangle is always 180 degree. Now let's take a clear picture to understand this. So here I have a triangle and it has three angles here. This angle, and this angle. When we add these three angles, the measure of these three angles, it will always sum up to 180 degree. So that means the measure of angle A, the measure of angle B, and the measure of angle C will always give us 180 degree in a triangle. Here you can see this angle, I measured it very correctly using a protractor, and it was found to be 29 degree, and it was 116 degree, and this was 35 degree. So now when I add these three, I get 180 degree. This is true for all the angles, for all the triangles. That is, the sum of the interior angles of a triangle is always 180 degree. Next we have the sum of the length of two sides of a triangle is always greater than the length of the third side. The sum of the length of two sides, when you add the length of the two sides, that is, here is 8 centimeter and the other is 7 centimeter. When we add 8 and 7, it becomes 15 centimeter. It is always greater than the third side. Now if you add 13 and 7, it becomes 20, which is greater than the third side, that is 8 centimeter. Similarly, if you add 13 and 8, it becomes 21 centimeter, which is greater than 7 centimeter. So the sum of the length of two sides of a triangle is always greater than the length of the third side. If it is not so, then you cannot form a triangle. To form a triangle, the sum of two sides of the triangle should always be greater than the third side. Now we have another property, that is the vertices of a triangle is used to denote it. Okay, here we have, again, I have a triangle here. A, B, C are the vertices. So to name this triangle, we use triangle A, B, C. I use the vertices of this triangle to name this triangle. So to name any triangle, we use the vertices and the symbol. The symbol is called delta, and it is used to denote a triangle. Here we have the triangle ABC. Okay, and again I'll show you one more. Here we have this triangle, and this is the name of this triangle is PQR, triangle PQR, or you can say PRQ or QRP. And the last properties of triangle is the area of a triangle is equal to half of the product of its base and height. Okay, here is where we need the perpendicular. The area of triangle is equal to half of the product of its base and height. So here again, the area of a triangle is equal to half of the product. The area of the triangle is equals to half of the product of base and height. Height means the perpendicular line. So we can use this formula to calculate the area of any types of triangle. But it can be done only if the perpendicular is given. If the perpendicular is present in a triangle, we can use this formula to find the area of triangle, of any type of triangle, if the perpendicular is given. Now we will learn to identify the base and altitude of a triangle. The base and altitude of a triangle. Altitude is the height or the perpendicular of a triangle. That is, altitude is sometimes called height. We usually use the word height in place of altitude and perpendicular. So it's the same thing. Altitude, height and perpendicular are the same thing in a triangle. Okay, base and altitude of a triangle. Let's understand what it is. You know, here I have a triangle ABC, and here we can see there is no any line segment that is perpendicular. So if I draw a line segment from the vertex A to the line segment BC, like this, and it makes an angle of 90 degree, then this line segment AD can be taken as a perpendicular, and this line AD is perpendicular to BC, so BC becomes the base and AD becomes the height or altitude or perpendicular. So this can be termed as altitude. So can be called altitude, height, perpendicular, and the line segment which is perpendicular to BC, so BC is called base. So now I'll draw another line segment from the vertex B to its opposite side. The opposite side is AC. If I draw a line segment from the vertex B and the opposite side becomes the base, and this, if it's perpendicular, this becomes your perpendicular, height or altitude, and AC is your base. So let me give it the name BM. Let it be BM. So BM is your altitude, height or perpendicular, and AC is your base. Again, here we have, in this triangle we don't have to construct perpendicular. The perpendicular is already present there. As you can see, PQ, the line segment PQ is perpendicular to RQ, so the line segment PQ can be taken as a height, or you can take RQ as a height or altitude or perpendicular. For triangles like the one you see in the picture, which is oblique, the perpendicular is always drawn outside. Here is the perpendicular drawn. This can be taken as the altitude of the triangle or height of the triangle or perpendicular. Since this is this perpendicular and the side opposite to this line segment, okay, let me give it a name, MX. The side opposite to MX is NP, so NP will be taken as a base. And here we have right angle triangle, and you know which is perpendicular. I already showed it to you. So this is what we did in this class, and in my next class we will be doing the calculation of areas and volumes of triangular prism. Till then, have a good time.